It's not a holiday. So 2 seconds, let me prepare my thing. Yes. Okay. Oh. What lecture number is this? 9 or 8 or 10? 10 should be even number, right? Let me guess it's lecture 10 then. I'll fix it later. Okay. And screen projector over there. Share screen. There. And I need to start window. Where is it? Next Thursday is a holiday. Wait, is it real or is it not real? Now you start. I start questioning myself. Is it real or is it not real? Not Named will have may or may not have the may or may not have makeup class. What else did I forget? The camera. NDI. Okay, there. Wait, where is? Wait, maybe I heard something about that as well. But typically, even if next Thursday is a holiday, I'm gonna make it non-holiday. That means makeup class right on that day. Yesterday, makeup class is not allowed, right? Because it's like seems more important-ish to people. Even if it's a holiday, I will make it not holiday. Okay. Or maybe we're gonna learn more on how to scam people. Like the whole class, we just play card tricks. That works too. Okay, I'll announce it. But remind me if I did not announce it today. This is like my 8 meetings of the day. so I might have missed something. Okay, so lecture 10. Reminder, homework 3 due tonight. Homework 4 start now, not 44. Homework 4 starts now, due next week. There are only 6 problems though. Read it now. This is not this is not a warning. It's an actual statement. Start now. Start now. Like, let me put an exclamation mark. At least read the question. There are only 6 questions, but it is hard. Actually, there are only 5, but it is hard. Okay, so lecture 10. Any question though? So the okay, let me tell you in advance as well. The midterm gonna cover homework 1 to 5. Okay, gonna cover homework 1 to 5. Okay. So here's what we're gonna do today. Let me teach you something about money. Okay, you now can tell your parents that I actually teach you like almost everything. What is money? What's MT? When is the midterm? It's about 1 week after homework 5. 1 week after homework 5. Oh, not 4. Homework 5. 5. Where's 5? It doesn't let me erase. Homework 5. Submission, not start though. So if you can do the homework, or at least if you struggle the homework by yourself, you are going to be just fine on the homework. on the midterm, on the homework. Okay. If you struggle a lot on the homework, then you're gonna be just fine. Okay. But if you like copy the homework without thinking, then you're screwed. You're screwed. Okay, lecture 10 is actually more sum. Actually, more sum. Yeah, last time we learned geometric sum, right? How much do you give us in the midterm? How much time you give? You have like, I'm talking to Ajahn Bu, Ajahn which is Ajahn of the other section. It's either one day, full day, or the whole weekend. Okay. But you should take it should take you like 2 to 3 hours to finish. That's what we designed you to do. That's what, and I give you a day or a whole weekend so that you so that you pick the time that you are right, like you have enough sleep and so on, then you start and so on. Okay, today I'm gonna teach you something about money. So here's a question. Here's a question. Okay, so let's say we want to compare two things. If I give you 1 million baht now, okay, versus 1 million baht later, like I don't know, 10 years from now, 1 year from let's say 10 years from now. Which one would you like and why? You like it now, right? Okay, that kind of makes sense. Like you kind of need the money now. What about what about if I give you 0.9, 900,000 and a million? Which one would you want? And how would you decide 0.9 million is 900,000? Depending on interest, very good, Peter. That means you're a business major or something, right? You kind of know, right? So let's think about this. There is an equivalent. There is an equivalent, right? There's an equivalent amount of money. So let's think about this. To get 1 million baht from now, do you really need 1 million baht today to get 1 million baht in 10 years? What do you think? To get 1 million baht 10 years from now, do you really need 1 million baht now? What do you think? No. Why is it? Why? Why don't you need a million baht? Why don't you need a million baht? Because you can put it on GameStop? No. Because you're rich already? No, I'm not that rich. But if you're rich, we can work out. No, guys, the whole point of cash is so that you don't need to work. You should learn something about passive income. It's so broken. The game is broken. Real life game is broken. So what do you do? Right, make money. Or what exactly do you do? Like the dumbest thing you can do to get the money work for you. Right, to put it in the bank, right? Let's say the bank or to put it in the bank and then you get an interest, right? So if you have X baht now, right? Then 10 years from now, it's gonna become 1 plus R to the 10, right? 10 years from now. I think everyone clear with that, right? Okay, everyone clear with that times X. Okay, which means R is the interest. R is the interest. Right? So for each year you have 1 plus, so the next year you get 1 plus Rx. So the next year you get 1 plus Rx and there are 10 of them. So 1 plus R to the 10. Everyone good with this? Right? So that means the money that you really need now, right? So that means this is a concept called the present value. Present value. Okay? the present value of a 1 million baht of 1 million baht 10 years from now is equivalent to the original money you need to put in the bank for 10 years to get a million, right? Which is X, which is 1 million over 1 plus R to the 10. Are we good? Right? Because if you put this much in the bank right now, right? If you put this much in the bank right now, okay, 10 years from now, what you're gonna get is exactly 1 million baht. Are we good? Is everyone good though? Is everyone good? Right? So I want to show you that is the future value of money, right? The present value of the future money. That's typically what we compare. Okay. So one lesson that you learn that you should not compare the value of the money at different time. They are not comparable. You need to normalize it by the interest rate. Is everyone good though? Is everyone good? Any questions so far though? What is this? Any questions so far? Easy enough, right? So essentially the present value, like present value is just X over, not X. Let me use another variable. Let's use ABC. Let's use A over 1 plus R to the n. Okay? So that's how you calculate the present value. So here's a real life situation that you're gonna get asked eventually. Okay. I need lecture note for all the calculation because it's quite tedious calculation. 2 seconds. Let me get the lecture note real quick. I need the numbers. Can you show the formula again? Yes. Okay. Are we good? So here's a real question. Let's say the car you want to buy, your first car. Your first car is $1 million. The price is $1 million baht. Okay. The price a car. Sounds about right. A car is about $1 million baht, give or take. And then you're given 2 options. The first option, okay, the first option is pay cash now. Okay, and you get some discount, right? Typically, if you pay cash, you get some discount now. So pay cash now and get 40,000 discount. Okay, which means if you pay cash now, it's gonna be 96,000. Okay, typically this is what happened. And then you are given the second choice as well. Second choice. Okay. Second choice is you can pay it by installment, right? So this is the installment. That means you can pay it like 50 term, right? 50 months. Okay, 20K each. So far so good? Anyone? Everyone understand the question, right? So you want to buy a car, you're given 2 options. The first option is to pay cash now, but you get some discount. The second option is you have 50 months, you pay 20K each month. Seem affordable, right? And this thing is like 4 or 5 years. Quite some long time. The question is, which one should you pick? What do you think? You want this car, but you want to be smart as well. Which one would you pick? And how would you decide what to pick? Probably 2, cash now. Why? Why would you pick one over another? Good, right? So we learned something about it. No, you don't pay the interest for the second one. You don't pay the interest for the second one. Right? So this is sort of this question, right? It's sort of the first question that I asked you, but it gets a bit more complicated because there are multiple future values, right? There are multiple future values. Okay, so this thing is like future, right? So you want to figure out what exactly is the present value of this guy. Right. So this is the future value, right? So we want to calculate the present value. Okay, we want to calculate the present value, but the present value for this one is a bit confusing, right? Present value for this one is a bit confusing because you pay, let's say at month number 0, let's say at month number 0 up to month number 49. Let me put down a table. Okay. At month number 0, you pay 20,000. Let me just put 20K to save my writing. You put 20K, you put 20K over here, you put 20K over here, and so on. Okay. Okay. Now, how would we calculate the present value though for number 2? How would we calculate the present value for number 2? What do you think? What do you think? Remember, the definition of the present value is nothing but the money you need now to make sure that if you put it in the bank, you will have that amount in the future. Right? So think about this. The present value of the 49 installment, the present value of this guy, the 49 installment, how much money do you need now though? How much money do you need now? How much money do you need now so that the 49 installment is that much? What do you think? Okay. How much money do you need now? No, not 1 million. You only need 20K at month 49. You only need 20K at month 49. Let's think about this. If you only need 20K for month 49, how much money do you need like now? 20K? No, right? We learned that if we put 20K and you wait 49 months, right, you're going to get more than 20K, right? If you put 20K now, you wait 49 months, how much you're going to have? You're going to have 20K times, times 1 plus R to the 49. But that R is a monthly interest. We can figure it out. That's not too hard. But you with me, right? The fact that if you need 20K, the fact that you need 20K at month number 49, that means you don't need 20K now. You need something less. So how much exactly do you need? Very good, right? That means you only need this much, right? Right? Which is going to cancel with that guy. Right? Which is going to cancel with that guy. You're going to have exactly 20K. So which means the present value of the installment number 49 is this guy. Are we good? Are we good? Are we good? Are we good? So let's do one installment at a time. Is everyone good with me though? Is everyone good with me? That means you don't need 20K. You did not pay interest, but the bank pay interest to you. Right, Patty? Patty, right? It's Patty, right? It's actually the interest that the bank pays you. Okay. So this, the bank pays you. Okay. Typically, when you say the interest rate, you meant this APR or APY. If you do crypto, then they typically call it APR because they don't do reinvest or APY. Annual percentage rate. I don't know what APY stands for. You can Google that up. But it's the interest that you pay the bank. Right. So that means to make sure that you have 20K to pay for the 49 installment, you only need that much money today. Okay, so far so good. So far so good. Actually, I'll teach you how to do the arbitrage as well. Right? Are we good? We don't need that much money. You don't need 20K to pay 20K 49 installment. Any questions so far though? Any questions so far? Right, now what can teach in my place? Okay, so what I'm saying is the following. If you want 20K by month number 49, you do not need 20K at day number 0. You only need this much to put in the bank and wait 49 months, and it's going to become 20K at month 49. Someone with me though? Someone with me, right? If you need 20K at month 49, you only need that much now. Put in the bank for 49 months, it's going to become 20K. Okay. If you have 20K at month number 0, if you have 20K at month number 0, month number 49, you're going to have more than 20K. Someone with me so far though? This is important point. Okay. So that means for month number 49, you need that much. Let me erase it. I need space. Sorry about that. So you only need, so that means the present value is going to be 20K divided by 1 plus R to the 49 RM. Okay. Someone with me though? If you have a question, just ask, because not everyone is finance major. I know. It should become second nature to you when you think about money. Okay. Is someone, any question though? Any question? Like, if you want me to explain it again, it's good. RM is, yes, interest rate per month is related to interest rate per year. It's not exactly divided by 12, but close by Taylor series. Okay, very good. Right. So that means you can guess, right? The present value of month number 3 is going to be 20K divided by 1 plus R to the third. And you need this much, 20K over 1 plus R to the second. This is 20K over 1 plus R. And this is, you need 20K now to have 20K now. Are we good? Sounds good, right? So that means for each installment, right, you need that much money. Okay. So here's a question. Here's a question. How much money do you need now to be able to pay every single installment? Anyone tell me? How many money do you need now? How much money do you need now to pay every single installment? Right? So for installment number 3, you know you need this much now to pay month number 3. For month number 49, you know you need that much. So how much money do you need now to be able to pay every installment? What do we do with all these numbers? What? Well, that's a thing called unit. Sum it up, right? Right? You just sum it up. You just sum it up, right? You can put it in like different banks, like bank number 1 to bank number 49. That works too, except, or you can put them all in the same bank. Okay. So not multiply. When you multiply dollar together, you get like dollar square, which I don't know what it means. Okay, so far so good. So here's what we need to do. What we need to do. We know. Okay, let me go to the next page and write exactly the same thing. So the present value of the installment of number 2, right, is going to be 20K plus 20K over 1 plus, oh, not 2K, 20K over 1 plus R plus 20K over 1 plus R square plus dot 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 plus 20k over 1 plus r cubed. Not r cubed, r49, sorry. And r is interest rate per month that we're going to figure out. I'll teach you quickly how to calculate it. R is RM, by the way. Interest rate per month. Is everyone good? Is everyone good? Does this guy look familiar though? You can actually put it in Python. If you know R, you can actually put it in Python, figure out what it is. Right. So if you want to be fancy, it looks like this, right? Sum of 20k over 1 plus r to the I from I equals 0 to 49. Right? That sigma, this thing. The actual symbol is called sigma, capital sigma. Okay. And if it just read the sum, it just means the sum. Just add all the number. Okay, think about it like for loop. Okay, guys. Does this guy look familiar? I like the top one better though. Does it look familiar though? How do we Python it again? Avast. You're kidding me, right? But I'll ask you something about Python. Okay, so you do this. What is it called though? What is it called? Do you remember? What is it called? Does this guy look familiar though? Looks familiar. Yes. What did we call it last time? It's called geometric series, right? Okay. Yeah, the actual term is actually geometric sum because you already sum it. Geometric sum, which means we can figure out what the value is, right? Which means we can figure out what the value is. So what do we do? So what do we do? What do we do to figure out what is PV? What do we do? What do we do? Multiply 1 plus r. Okay, that's smart. Okay, we know 1 plus r PV, right? There are going to be people who actually remember the formula. I don't. 1 plus r multiplied by 20k, right? So what Peter was saying that it is annuity is when annuity actually refer to what happened when you sum this guy to infinity. It's not exactly that one, but close enough. Okay, 1 plus r 20k plus 20k over 1 plus r. So I'm going to drop the m, but you get the idea. The last term going to become what? 20k over 1 plus r to the 48. What do we do next? What do we do next? I multiply 1 plus r, just like you said. What do we do next? What do we do next? What do we do next? 65 by 1 plus r. Now we want to write the right-hand side in terms of the present value, right? The PV. What is it? Tell me. Very good. So all these guys are sort of PV, right? Except that there's a missing term somewhere. There's a missing term. So it's going to be 1 plus r times 20k, right? Plus PV minus 20k over 1 plus rm to the 49. Okay. And then the rest, I know you know what to do, right? So you just move PV to the other side, right? So it's going to be R times PV is going to be 20k 1 plus R minus 1 over 1 plus Rm to the 49 over, and then let me move R. Yeah. So far so good, right? So the right hand side, you can calculate it. If you know RM, you can just plug it into Python and then it gives you the answer. Okay, so if you know monthly interest, which I calculated for you though in the lecture note, that's why I need the notes. Any questions so far though for this one? I think it's just algebra, right? Any questions so far? So there is one little problem, right? At RM, we need to figure out what to find because we know when the bank quote you interest rate is typically is yearly interest rate. So we just need to do the equivalent, right? That if you put in the bank for 12 months, it should give you exactly 1 year. Right? And then you can solve for RM. Right? RM is going to be 1 plus RY, O1, O12, and then minus 1, and so on, which I calculated for you already is RM is what? I calculated for you already. RM is, oh God, did I calculate it? Oh, there, 1.6 times 10 to the negative 3. Okay, and then I calculate the present value for you already. For this guy, it becomes 96, 0, 6, 2, 1. I just put in this number for you already. Okay. Everyone good? Everyone good? Like if you put in the number, you get this. If I did not screw up the algebra. Okay. So which means to be able to pay 50 months, to be able to pay 50 months, how do we solve for RM from here? RY is like 2%. Are we good, Thanakat? So you only look on the right. If you put money in the bank for 12 months, that should be exactly the same thing as putting the money in the bank for 1 year. Okay. So you solve for IM, then you plug it in on the left, and you get some number. So that means you know that to do this, right? To do this, you need 96,006 to 1. Okay. So now here's a real question. Which one would you like to do? The first one, right? That's all. It's the first one that you want to do. But I typically do the first one, even though the second one comes out cheaper. Because I tend to forget that I have to pay for 50 months, and if it's not automatic, then I'm going to screw up some of the month, and then I need to pay fine and so on. Okay, is everyone good? Yes, I do. Like my another car, I calculate this. Right, you can take extra 621 baht. And if you think about it, you actually take more than 621 because at month 49, when you are done, that 621 baht becomes a lot more. Right? It's probably become 700 baht or so. This concept is actually called, that is actually a very general technique. Peter might know it already. It's called replication. It says that if you can do the same financial action, do the same finance two, let's call two financial ways to finance action, to finance sequence of action, two sequence of action. So let's say if action A and action B give you the exact same payout, the present value should be the same. If not, then you have arbitrage. If you're interested, then go read something called mathematical finance. That's actually should be the first thing you should be taught. I think someone teach it at MUSC. I don't remember who. Maybe Ajahn Jack. I think Ajahn Jack teach it. Some sort of mathematical finance. Okay. If you're interested, though, or maybe Peter can suggest people. Okay. Oh, so here, I mentioned something about Taylor series, right? So your first thought, think about this. If I say that, okay, yearly interest rate is 2%, right? This is a good question. Yearly interest rate is 2%. Your first thought would be, okay, how much do I get per month? Your first thought would be, okay, Ajahn, that's easy, it's 2%. Divide by 12. Right? That would be your first thought. But that neglect the effect of the, what's it called? Of the accumulating interest that you get over the year. Okay, this is your first thought, which I say that this guy is actually really close to this guy. And the reason is the Taylor series. It's the following. So 1 plus RM to 12. Okay, think about this. This RM, this is small. Okay, so if you do Taylor series, the first term, I think if you do NumMed homework, which you guys should do, a lot of people haven't handed in, you're gonna get 1 plus 12 RM plus something on the order of RM square, which RM is small, so RM square is like really small, so we ignore it, and that has to be 1 plus RY. So when you solve for it, that if you ignore this, if you solve for RM, what you're gonna get is that RM is going to be RY over 12. Yeah, so it's related to Taylor series. Are we good? That's what I meant. Okay, but that means your intuition is sort of correct that if you ignore the higher order terms. Now you see everything is connected. Must be noted? No. It's just cool, right? It's just cool that if you haven't taken the numerical method, you're confused, it's okay. Or maybe even more confused if you take numerical method. It's okay. It's okay. Don't worry. Don't worry. There's a math behind it. That why is it that RY over 12 is sort of the correct answer. Okay. Your intuition actually says something really close. Okay. You're gonna appreciate it once you know Taylor series. Okay. So here is something that is risky here today. Okay, let me find him. Today we only have 21 people. I don't know what happened. Like they gave up on live. Is Risky here today? Risky is not here today. I was gonna teach him something that show up in physics, and most people have no idea how to do. Okay, so let me show you something. And no cat cam. Yeah, where's Saran? Okay, so let me show you something. So for example, if I ask you the following, right? If 1 plus x squared, something is wrong with my pen. It doesn't feel right. Plus x to the third, plus x to the fourth, and so on. Okay, and there are infinite of them. And let's say x is strictly less than 1 as well. X is strictly less than 1. If you sum up to infinity, what is it equal to? Okay, if you sum up to infinity, what is it equal to? So you can do the same trick, right? Just call this your favorite number. Let's call it k. Okay. Oh, Saran is here, except not the cat. And then the next thing that you do, right? You multiply x on both sides, like usual, right? You're gonna get x plus. Something is wrong with my pen, really. Doesn't feel right. X squared plus x to the third plus x to the fourth plus dot dot dot. So that is exactly 1 minus x. Sorry, let me close this and reopen it again because it doesn't feel right. And then when I write it, it's not smooth. It's really not smooth. Now that's smooth. Now I fix it Windows way. Okay, kx is 1 minus x, so you can solve for k. K is going to be 1 minus x over x. Right, if I did not screw up. Did I screw up? Wait, not 1 minus k. All right. Wait, k minus 1, not 1. K minus 1. Kx is k minus 1. So that means k is 1 over 1 minus x. Okay. So far so good, right? Nothing fancy, but this thing is something that you should know, that 1 over 1 minus x is 1 plus x squared plus x cubed and so on. Yeah, this is a useful thing to know. Or you would be surprised to know the backward. 1 plus x squared plus x cubed plus dot and multiplied by 1 minus x. That's a 1. So you would be surprised the right one, but the left one you may. Why k minus 1? Because k is this guy. This thing is k without the 1. Are we get? The second line is k without the 1, so that's k minus 1. Okay, so let me ask you. There are actually multiple ways to do this. This thing actually shows up a lot. Right, solve the algebra, or did I screw up the algebra? Right, solve the algebra, right? Okay, let me put it step by step. Okay, so it's k x minus 1 is minus 1, right? So that means k is minus 1 over x minus 1 equal 1 over 1 minus x. Are we good? Know what? Let's make sure I did not screw up the algebra. We're gonna do a real algebra next time. Okay, any questions so far though? Any question? Okay, if not, then let's go on. Let me ask you. This thing is easy. That's easy. Okay, let me ask you. This thing gonna show up a lot. What about this sum? X plus 2x squared plus 3x cubed plus 4x to the 4th plus 5x to the 5 plus dot dot dot. What is it equal to? Anyone has a good idea though? This thing actually shows up a lot. Shows up like more times than you think, especially in physics and finance. This thing shows up a lot. What's it equal to though? Anyone has a good idea? Even if you look at it, these two guys, they are almost identical, except one annoying fact that you have that constant in front. What do you do? This thing show up in statistical physics, which got the Nobel Prize last week or last 2 weeks. I don't remember. But I think one of the first guys who figured this out is probably Boltzmann or something. Maybe they figure out before that, but the first time I see it has to do with Boltzmann. Okay, anyone has a good idea though? Anyone has a good idea how to find out what this sum is? What's the difference between the two? You lost? I just want to find this sum on the right. I just want to find this sum. Let's call that P. I just want to find this sum. What is it equal to? Like, so for example, if you think about it, this sum has a very nice formula. I would hope that this sum should have a nice formula as well. What do you think? Oh, close, right? Think about it. So the goal here is, if you have a way to transform the right-hand side so that it looks like that right-hand side, is there a transformation that sort of do that? Something really close? What do you think? What do you do to make the right hand side equal? What do you need to do? At least you kind of sort of need to bring the coefficient down, right? So what kind of operation does that? The derivative. Think about this. If you take the derivative of the right, okay, so let's do this. D by dx of that thing, right? 1 plus x squared plus x cubed, and so on. That is 1 plus 2x plus 3x squared plus 4x cubed. Oh, so close, right? But not quite. How do you make them the same? How do you make them the same? Multiply by x. Very good. So, but if you multiply by, if you take the derivative first, right? If you take the derivative first, then multiply by x, then you're gonna get exactly what you need, right? Right? Everyone agree, right? Everyone agree. If you take the derivative and then multiply by x, you're gonna get exactly what you need. So let me ask you the real question. So what is this guy equal to? What do you think? What do you think? What do you think? If you do this to the right hand side and it looks equal, very good, right? So all you need to do is do exactly the same thing to the left hand side. Do exactly the same thing to the left hand side, and then that should be my answer, right? Because I did that to the right hand side and it works and it matched. So if I did the same thing to the right hand side, then it should, to the left hand side, then it should work. So this thing should be x d by dx of 1 over 1 minus x. What's up, Peter? Why the exponent increased by what? Because you multiply by x. Huh? Right? So, so before we take the derivative, taking the derivative is easy, right? So you want to manipulate the right hand side so that they look the same. And you know the manipulation that you need to get the right hand side to look the same is you take the derivative and multiply by x. Right? Because when you take the derivative, you take the power down, except the power is decreased by 1. So you multiply by x to get it back. Okay. So that means, you know, to get the right hand side to match, all you need to do is do this. So that means you just need to do the same thing on the left. And then that's going to be your value. That's all. Okay. Actually, chemistry, you should see this when you do like statistical mechanics. If you learn chemistry later, you're going to need to do statistical mechanics in some form. And then you're going to see this sum. And then you can mention, okay, Ajahn, I taught you in discrete math and so on. Maybe chemistry is a wide field, so maybe you will never see it. Maybe you would never see it. Okay, so far so good. But everyone can take the differentiate this, right? Maybe. What do I guess? 1 over 1 minus x squared. Right. That's all. Right. So this thing is x over 1 minus x squared. What does this actually tells us again? It tells you that that sum on the right is x over 1 minus x squared. That's all it says. And I just show you because some of you are going to see it once in your life, somewhere, somehow, and you don't know where it's going to show up. I just show you that, okay, that's an easy way to get it. What about it cancel? It cancel, right? So you pull down the negative one here, and then you d by dx is chain rule, then negative one, you have two negative ones, so it becomes plus one. That's how I'm good, right? There are two negative signs. Yes. Okay, so I show you this. Okay, any questions though? Any question? We are trying to show that these two guys are equal. Okay. We don't even know the left hand side. Okay, so any questions or any questions? Just so this is not going to be on a test. I'm just trying to tell you that if you see it again in your life, you know how to get it, how to get your answer. There's another answer like asking Wolfram Alpha to maybe if you know what to type, then it's gonna work. Okay, so if no question, we're gonna take 10 minutes break and then gonna come back and learn something very easy. Okay, we're gonna learn something really easy. Or maybe really hard. I don't know. Let's come back at 15:03. Yes, you're gonna learn how to scam people again. Maybe not today though. Maybe not tomorrow. You're gonna learn about poker though. Poker is actually the game of skill. It's not a game of luck. It's a game of skill. Play it with Vicky. Vicky loves playing poker. You know Vicky, right? Your Runpi, one of them. He bought the whole set of how to play poker and he put it in 1502. Except you cannot enter it now. We have the chip and everything. So make sure that when you play, you close the door or something. You close the door. No one gonna complain though, because that room has like a lot of cards and the board games. Actually, the purpose of that sticker is not for that reason, but they put it in the wrong direction. They put it on the wrong side of the mirror. The purpose of that sticker is so that you can write on the mirror and you can still see what you write. Except someone put the mirror on the wrong side, put the sticker on the wrong side of the mirror. Now you cannot write it. We thought about rotating the mirror, except it's too hard. Like reapplying the sticker is also hard, so we just gave up. Right, the math should be written on the inside, and then the sticker should be the outside. Okay, I guess everyone is back. So let's do this. Let's do something very simple. Okay. Let's learn about the property of the sum, the thing that you found, right? the property of the sum. You can actually write a formal proof, but let me get your intuition instead, because the proof is actually very easy to write, but the intuition is actually more important to know what to do. Property of sum. Okay. Now, let me ask you the following question, guys. Sum of 5 times, I don't know, I. What is it equal to? What is so tempting to do with the 5? Actually, what is so tempting to do with the 5? Okay, you can say I equal to 0 to n, doesn't matter. What's so tempting to do with the number 5? Anyone? Anyone? Are you guys still here? What's so tempting to do with 5? So think about this.
Working.
What is not working?
I think your chat is not moving, Ajahn.
What's wrong with my chat? Wait, I blame Sue. Very good. Okay. Actually, it really doesn't move. Why? Okay, now it moves. Okay. Technology is mysterious. Okay. Now it works. Okay, right. So everyone would think that, okay, you want to pull out the eye, but you're not sure, can I do it or can I not do it? This is the thing that why I want to teach you the intuition rather than how to actually prove it, because once you get the intuition, you know what to prove. Okay, so tempting for you to do it, but you were still like, Ajahn, can I really do it? Can I really not do it? I don't know. Typically what you do is exactly what I tell you not to do, which is prove by example. So, so let's write this guy down exactly what it means, right? This guy says 5 times 0 plus 5 times 1 plus 5 times 2 plus 5 times 3 plus 5 times 4. This is exactly what the symbol tells you to do, right? So which means all you need to do is factor out the 5, right? Once you get that, you have 5 and then 0 plus 1 plus 2 plus 3 plus 4 and so on. So that means it's going to be 5 times the sum of I from 0 to n of I. Okay, so far so good. So the first rule that you learn, right? The reason that I show you this is so that you can check yourself really quick that this move is valid or not. The only thing you need to do is just write them down. Just expand them. What exactly does it mean? The symbol is so compact so that you have no idea what it means. Okay, is everyone good? Right? So the first thing you learn is that the constant, sum of constant times any function of xi, right? It's actually just put it out. Actually, it's the same rule as integral because integral is a sum. Anything you learn about integral sort of works here as well. Okay, so far so good. How about this one? How about this one? Sum of fxi plus g of xi. Okay, the symbol looks so complicated, right? Yes, k is constant. If k is constant with respect to WRT is with respect to I. Right? This is actually the key. We're gonna see this later. Okay. What's so tempting to do? What's so tempting to do in this case? You want to distribute, right? But you are not so sure. If you think about it, you're not so sure, right? You're not so sure. Can I really distribute the sum? This is the way that you make sure. Just write it down. Okay? Because you're gonna get to something more complicated, and then you're gonna need to ask yourself, okay, is it true or is it not true? You're gonna get fx0 plus g of x0 plus f of x1 plus g of x1 plus f of x2 plus g of x2, and then so on. And then you can start grouping them, right? So the f are together, and then the g's are together, right? So in the end, you get fx0 plus fx1 plus fx2, and so on, plus g of x0 plus g of x1 plus so on. And then you convince yourself by now that this thing is actually sum of xi plus sum of gxi. Okay, the important thing is not for you to memorize all the properties, so, but the important thing is that you know how to check your intuition, whether it works or not. Okay. Is everyone good? Everyone good, right? The important thing is not for you to memorize the properties. The important thing is you have some property that you think it should be true. Can you check? Right? Can you check and say that it's true? Because after you know this, you can actually formalize it and write a proof. I'm pretty sure you know how to do that by now. Okay, it's gonna look something like this guy. Okay, let me ask you another one. What about this guy? Sum of I from 1 to n of number 7. What is it equal to? What about, what's up, Keith? Okay, sum of from I equal 1 to n of 7. Very good. You get 7 times n, not 7. So many, well, okay, so many people are gonna say it's 7. No. You add 7n times, you should get 7n. You're gonna be surprised how many times you get it wrong. How many people got it wrong? Okay, you add 7n times, you should get 7n. Okay, not 7, just to make sure. Okay, so now here comes the problem. Here comes the problem. So let me ask you the following. What if you want to sum this thing up? What do you think? What's so tempting to do? What's so tempting to do? Pull it out. Okay. So you may think, okay, Ajahn, yeah, I might be able to pull this guy out. Can you? Or can you not? Exactly. You cannot do it. It's not exactly the same rule like last time, right? Last time, that guy needs to be constant as a vector. Actually, that's smart, but no, that's smart. Actually, it is a dot product though. If you think about it, it's a dot product. This thing is a dot product, the thing you learn in physics and Calc 3. Right, so let me ask you. Let's say your intuition say, Ajahn, I should be able to do the following. Right? Your intuition might say, okay, I should be able to do the following, right? What do you think? What do you think? What do you think and why? How do we check if the move is valid? I don't know. They may come out to be equal though. How do you check that the move is valid or maybe invalid? Good. Try with some example. Okay. What is the easiest? So what example? Now what can you suggest me something? What's f of xi? Can you give me some example? Something really easy. Okay, I plus 2. Not bad, not bad, not bad. Okay, fxi is I plus 2. What about g? Okay, let's call xi is I plus 2. Okay, and maybe the other guy is I minus 2, right? So as let me give you an easier example. Let's say f, right, is something like 0, 0, 1. So, and then all the rest are 0. So that it's easier to do. Okay. And g is 1 and then 0, 0, and 0, and so on. Right. Typically, when you give a counter example, you should give something easy to compute. You can do exactly what you did, I plus 2 and I minus 2. Right. So this is just the function that fxi is 0, except when I is that position. G of xi is 0, except when g is that position. So the left-hand side, what do you get? Can anyone tell me what you get on the left-hand side? You multiply them and you sum it up. What do you get? You get 0, right? Because every time you multiply the 2, you always get 0. The right-hand side, what do you get? Tell me again, Karit. Tell me again. So close. So close. 1, right? Because if you sum up all the f, you get 1. If you sum up all the g, you get 1. So this is 1 multiplied by 1, which they are not equal. So you cannot do this. Don't do it. Okay. And this is why I teach you not the property, but exactly how you would check yourself whether this property is true or not. Right. And the way you check it is exactly what I told you not to do, is to check it by example, right? At least if you pick a random example. If you pick a random example, if it works, it works. If it doesn't work, then you know exactly it doesn't work. Right? Sum of f is 1, sum of g is 1. Well, so you cannot do this. Do not do this. Never do this. This is the sort of like so many things that went wrong in our world. Okay. This actually related to 2018 financial crisis. Right. We want to show that it's true for every f, right? And we just show that, okay, that's one if it doesn't work, right? You know how to give a counter example. Right? Not only that you learn how to prove, make sure you learn how to disprove as well in the midterm. Right? Disprove is easy. Just give me a counter example. That's all I need. Okay. Anyone? Any questions so far? Or any questions so far? So let's do another one. Let's do another one. Why am I muted? Why am I muted? Someone did something. Let me go back. Why am I muted? Okay, so let's do another one. This is gonna look a little bit confusing. Okay, so what I'm gonna do is the sum of I equal 1 to n, the sum of j equals 1 to m, f, let's just call I times j to make it easy. Actually, it doesn't really matter. Are you with me so far? Though?
Rose again.
Internet is not my friend. Why does it hit me? My microphone sounds different. Wait 2 seconds, wait 2 seconds. Let me fix the microphone. I think it changed my microphone as well because I know that it should not look like this. Microphone. Does it sound better? Does this one sound better? Okay, because this guy is way more expensive than the other guy. I don't know. It kicked me off. It doesn't allow me to share and so on. Okay, so let's consider this, the sum. double sum. This is called double sum. The name is called double sum. But then you start, okay, Ajahn, what is this alien symbols? Let me put in the parentheses. Okay, so let's try to understand it first and then see what's so tempting to do. Right, if you think about nested loop, you are thinking about it right, but also you're wrong. But okay, let's think about it. Since you say nested loop already, if you want to write Python code for this, how would you write it? You would do something like this, right? S equal to 0 for I equals 1 up to n, for j equal 1 up to m, right? And then s plus equal n I times j. Okay, what's the big O of this? What's the big O of this? Did Ajahn teach you about the complexity already? Or not? Maybe. Right, time complexity. What is it? Okay, so you can think about n square or maybe n times m because this sum happens in total n times m time, or you can think about it as like n square if n and m are equal, right? Can you do better? Can you do it better? This is a real question. Can you make it better if you want to make this sum? No, it's actually okay. That's partly true. Right, you can sort of like to for it once, and then you want to do it less than n by m times, right? If you think about it, if you think about this, before we do the math, let's try to do it like computer scientists. This loop, what do you notice? Can you do something smarter than that loop though? At least you save some operations. At least you save some operation. Use while loop. No, that's the same thing. It's compiled to exactly the same thing. Use if no. What do you know about I? In this loop, what do you know about I? What do you know about that I? It's a constant, right? It would be smarter instead of having to multiply like m times over here. What about if I compute like tiny sum, right? If I compute a tiny sum like, and then just multiply the whole thing by I, right? Right. Then you save some operation. We want to do something exactly along that line, but we're gonna get back to this later. But we want to do exactly something along that line. Okay, so far so good. This is a goal. You want to do something exactly along that line. Now when I write the code, you see more exciting. You're more excited. Okay, so let's think about this. If I want to do exactly the same move that I show you in the for loop, what should I do with that I? What should I do with that I? If I put in all the parentheses, what should I do with that I? I should pull it out, right? Right? I should pull it out because that I is a constant with respect to J. So you may not see it now. So let's think about this. This sum looks like this. This sum looks like this. Okay. So in the first loop, in the first time that you do it, right, it's gonna be 1 times 1 plus 1 times 2 plus 1 times 3 plus 1 times 4, and then 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4, and so on. 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4, and so on. Okay. So the first number is I, right? The second number is J. This is exactly what the operation tells you to do, right? This is what happened when J is 1. No, when I is 1. This is what happened when I is 2. This is what happens when I is 3. Okay, so far so good. So you're gonna learn. So for example, the second part, right? That I has nothing to do with J. So you should be able to pull it out. That 3 also has nothing to do with J, right? I should be able to pull it out. Are we good? So that's exactly the same idea as why we can pull out the I. Okay, so far so good. We're gonna do something better. That's still n square, by the way. So that's still n square. So far so good. So we have this. We have sum of I equals 1 to n, and then I, and then sum of j from j equal 1 to m. Okay, let me put in the parenthesis. Okay, everyone good so far though? Let me make sure everyone good so far. Everyone good so far? Okay, if you good so far, then we're gonna continue. Think about this. There's something stupid about this. Okay, there's something stupid about this because this thing, if you write it as a code, there's something really dumb going on with this. Because if you write it as a code, then you're gonna say that for I equal 1 to n, and then I'm gonna do, I don't know, let's say call t is equal to 0, right? And then I'm gonna do for j equal 1 to m, t plus equal j, and then I say that f plus equal I times t, right? S equal to 0 over here. Everyone good so far though? There's something really stupid about this code. Can you tell me which one? The innermost loop. What about it? What about it? Yes, you have two loops. That's not a problem, right? Python can take it easily. Very good. The innermost loop. Think about this. When I equals to 1, when you do this whole loop, when I is equal to 1, you do this whole loop, right? You get one number. When I is equal to 2, you do this whole loop again. You're going to get exactly the same number, right? When I is 3, you do this whole loop again. You're going to get exactly the same number. Are we good? Is everyone good? Everyone good, right? Or in other words, if you think about it. Okay. So think about this. When I is 1, you calculate this guy, which has nothing to do with I. Right? You calculate this guy has nothing to do with I. So when I is 1, you're going to get the same number, right? That t over here going to end up with exactly the same number. Right? When I is 2, you calculate t again. You're going to end up exactly with the same number. Or in other words, this guy, that sum over j here, has nothing to do with I. Okay, this is important point. That sum over here has nothing to do with I. This is a constant. Okay. Someone good? That sum over here is constant with respect to I. Are we good? Okay, I want you to see this. That this sum over here is constant. Even though it doesn't look like a constant, it's a constant with respect to I. Which means, think about this, Keith. Okay, maybe if you're confused, think about this. If m is 5, if n is 10, I don't know. Then you are calculating that exact same thing over and over, right? Over and over because when you pull out the 2, the thing that you left with look the same as what you left with 3, right? So this thing I claim is equal to this. Okay, so this guy is a constant. You pull it out. The reason I put j, it actually doesn't matter. It can be any function of j. It can be any function of j. It doesn't matter. Okay, so far so good. Now tell me. Is someone good? Any questions so far? Or any questions so far? Tell me, what's the big O complexity of this? What's the time complexity of this? How many times do you need to add? For those of you who take advanced class already. Let's ignore the 2. It's n plus m. Right? Because you have 2 for loop. The first time you add m times, the second time you add n times. And then you multiply it once. Okay, so think about this. The number of operation that you need, let's say n is 1,000. Let's say n is 1,000,000. And m is also order of 1,000,000. So this thing, you need to add up 10 to the 12th time. 1,000,000, right? This thing you only need to add up like 2,000,000 times. This is a lot faster. This is linear time. This is a quadratic time. So sometimes you simplify the math and your algorithm run like infinitely many times faster. Everyone good? Any questions so far though? Any questions so far? There are a whole bunch of magic to do with the double sum, but it's if you think about it, it's based on like simple rules that we learn, right? You can pull out the constant, you can distribute the sum, and that's all. It's how long? Think about it's like order of magnitude of how long it takes to run. Don't worry if you don't know. Don't worry if you don't know. I just want to show you that there's a connection between this class and all the other class that you're gonna learn eventually. Okay, so let's do another one. Let's do another one. We have the sum already. Some of you may have seen this. I think Keith might have seen this. This symbol. Okay, this symbol, the capital pi. Yes, it's a product. It's a product. So pi from 1 to n of I. Okay, so that is equal to 1 times 2 times 3 times 4 times not plus times 5 blah 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 times up to n, and there's another name. It's called n factorial. This is actual mathematical symbol. This is called factorial. Okay, this is called a product, and that's all the definition there is. Yes, there's a capital pi. That's a capital pi. I think LaTeX is /prot or /pi. I don't know. /prot. I think /pi like this works too. Okay, it's called a product. This is the product. Okay, so let's do this. Let's do exactly the same exercise that we did. What if I try to find this? Yes, now you know it's a product. It actually shows up a lot when you do probabilities, because probability they multiply. Okay. What do you think I should do with 5? What do you think I should do with 5? What's so tempting to do? Put it out again? Okay, let's do this. Is it correct? How would you check? Is it correct? No, right? No. Okay, let's think about this. We don't know. You said no. So let's check. The easy way to check, like I said, I'm not teaching you the property. I'm teaching you how to get the property in 10 seconds, which I'm gonna take. It's gonna take it more than 10 seconds to teach you. Okay, so it's gonna be 5 times 1, right? Times 5 times 2 times 5 times 3 times 5 times 4 times dot 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 times 5 times n. Aha. Right? So you now know that there are more than 1 5, right? There are n of them, which means when you pull this guy out, it is going to be 5 to the n. Do not forget this guy. Multiplied by pi. Okay, any questions so far? Any question? I need a product. There's another property that I need to teach you. Right, just rearrange. What about this? What about this? I plus j. The product, the actual name is product. I of I, let's say plus I square. It's another function of I. Doesn't matter what it is. What do you think is equal to? Any guess? Can I distribute it, right? You know that it's so tempting for you to do. What do you think? Is this true? How do we check? And how do we fix it? What do you think? More example. Yes, you speak more example, right? but let me tell you, no, they are not. You can find the example real quick. No, they are not equal. You can find the example real quick. They are not equal. Don't do it. Don't do this. Okay. Okay. How about another one? How about this one? How about this one? Since we have some time. Okay. I need to do two things. Okay. Pi of I equals 1 to 2, which is a stupid thing to do. No. It's not the best way to prove, but it's the easiest way to come up with to check whether the property you guess is correct or not. Should work or not. The easiest way to check, but it's not a proof. We have learned. Don't prove by example. And then I said it's not a proof, right? But the intuition is very important to give you what exactly is it you try to prove. Okay, and then let's say let's just do this 2 to the I times 3 to the j. Okay, let's do this one. Any guess? Can we do this like the magic thing that we did last time, right? Is pi of 2 to the I. What do you think? Or something similar, right? Let's figure out what to do. Anyone has a good idea though? Anyone has a good idea? Anyone has a good idea? We want to do something like what we did earlier. Very good, right? So you notice that this guy, 2 to the I, is a constant with respect to j. That means you can pull this guy out, except when you pull it out, don't forget the power, right? The 3. Don't forget the power over here. So you end up with pi I equals 1 to 2 of 2 to the, actually, let me just put n and m to make my life easier. Sorry about that. 2 to the mi pi, let's put in the parentheses, pi from j. Okay. When I update the iOS, it does something stupid. from j equals to 1 to m of 3 to the j. What do we do next? I actually have good notes installed, except all my notes are saved in here and I cannot move. I do have good notes. I do have like almost every notes app, but I use this one. Anyone? What do you do? What do I do with this? What do we do with this? This guy. A lot. It's not a lot though. It's like 200 each, right? Typically, the app sells you like 200 baht each. But what do you do with pi of j, the product of 3 to the j? What do you do with the product of 3 to the j? What did we do last time? No, you cannot pull the 2 out anymore. You cannot pull the 2 out anymore. Right? Because that 2 to the I has something to do with I, you cannot pull it out. What did we do last time with this guy? What did we do? This guy, remember, right? You want to pull that thing out, right? Because it has nothing to do with I. That whole thing has nothing to do with I. So you want to pull it out, except it's pi j equal 1 to 3 of 3 to the j, except now you have the power n. Right? Because you pulled it out from the product, you have that power. Everyone good? With me so far, you with me so far. Okay. Now, how about this guy? What do you want to do with n? What do you think you should do with n? What's so tempting to do? What is so tempting to do? Distribute inside, right? So think about it. You are not so sure, right? Think about this. You are multiplying from, oops, this is m. J equals 1 to m, right? Of 3 to the j, and then you do that 3 times, like n times. And that n of them. Then you know that this thing, I think you're convinced, right, that it is going to be the product of j equals 1 to m of 3 to the m j multiplied by the product of I equals 1 to n of 2 to the m I. Okay. Which you can actually find the closed form and so on. About that to be n. Any questions so far or any questions so far? Okay. This isn't gonna take too long. Can I wrap this up again? Yes, I can if you want. So we want to find the double product. I is not equal to n. So you want to find the product from I equal to 1 up to n and j equals to 1 up to m of 2 to the I times 3 to the j. This thing actually shows up a lot in probabilities. Okay, so so the first thing that you do, right? You know that 2 to the I has nothing to do with j. You pull the 2 to the I out, but whenever you pull a constant out from the product, you need to raise it to that power. So this thing become like 2 to the I to the M, which you know is 2 to the MI. Okay. Right, this guy. Okay. And then left over whatever you left over with, which is product of J equals 1 to M of 3 to the J. But then you notice it's a product of I, but this guy has nothing to do with I, it's a constant, which means you can pull it out, right? You can pull this guy out, but when you pull it out from the power, from the product, you have that N power with you. So you have this guy, and then you can convince yourself that it's just this guy. It's just this guy. Everyone good? Okay. Any questions so far though? I think I don't have enough time to start something new. We're gonna continue next time. Any question? Okay. If not, the homework due tonight, by the way. Homework 3 due tonight. And homework 4 start now is hard. Homework 4, if you want a hint, the generic hint is just to play the game a couple times and then you'll see. Play the game. There are like 5 games for you to play. Typically, the hardest one is the Pokemon one. So the hardest one is the Pokemon one. Yes. The hint is to play the game. Pokemon one is the hardest one. It's actually not the hardest. It's actually the one that gets you the most confused on how it works. Have fun, you guys. Scream on Discord. Someone gonna come and help. But you only have 6 problems though. That's a good news, right? Only have 6 problems though. Okay. So bye everyone. See you next week. Bye.